Hey friends, welcome back. So today we will see another video of supervised learning. So basically again this is a problem of classification. So for example we are having a mobile price classification example. So let's start with the problem statement. So basically market size of mobile phones is growing every day, and so is the competition, right? To capture the maximum market, electronics companies try to make improvements in their products. However, sales of mobile phones depends on various factors like demand, technology, marketing, brand availability, user experience, service price, etc. As we understand that a selling price makes a huge difference when it comes to sales and profit, right? So estimating an optimal price for a few mobile phone can be a tricky task, especially when you are new in the business or when you want to launch a new kind of mobile phone in the market. So as part of this exercise, we will try to estimate the price range for given mobile phone using given feature information. So these details are collected from various similar companies. So this is the attribute information, that is all the attribute in our data set. Now the table of content that will be doing importing data, setting options, reading data, data analysis and preparation, in which we will do understanding and with the data types, summary statistics, missing values, right, correlations, discover outliers. Finally we will apply logistic regression, and then the conclusion. So let's start with the first option, that is the importing libraries. So first thing, we are importing warning. Hope you remember that warning is basically used to suppress display of warnings, right? So all these warning that you get in between your elements, so that will be ignored. Now secondly, we importing OS. So OS is basically used to provide a way of using operating system dependent functionality. We use it for setting working folder, right? So this is the OS. Now pandas, that is obviously for data manipulation and analysis, okay? And numpy to use for all the numerical operation like multi-dimensional array and matrices, along with the mathematical operators on these arrays, right? Then we will do matplotlib, that is a data visualization library for 2D plots of array built on numpy arrays, right, and designed to work with the broader scipy tracks. So next thing, we are doing import matplot.pyplot as BLT, right? Then we are using matplot inline, and from matplotlib importing pyplot. Next thing we are doing is Seaborn is based on matplotlib, which aids in drawing attractive and informative statistical graphic. So we are importing Seaborn as SNS. Now scikit-learn feature various classification, regression and clustering algorithms. So this is the libraries that we are going to use. Trend test split from model selection, the logistic regression from sklearn.linear model, matrix from sklearn, pre-processing from sklearn, and from matrix in sklearn we are importing average precision score, confusion matrix, accuracy score, classification report, plot confusion matrix, right? So let's do the second step, that is setting options. So first thing, we are suppressing our display of warning. So warning dot filter warning, we are ignoring everything. Now display all data frame column. So pd dot options dot display dot max column, that is also none. Now to set the limit to 3 decimal, obviously we will use pd dot option dot display dot float format, that is from beginning to 0.7f, right? So in that format. Now display all data frame rows. So to get that, pd dot option dot display dot max row equals to none. Now let's start with the df, that is reading csv, that we have mobile.csv, which I'll provide a link in the description as well. Next thing, we have to display the top 5 row of the data frame, that is df dot head. Okay, so here you can see this is the CSV that we have. Fourth is data analysis and preparation. So data preparation is the process of cleaning and transforming raw data prior to building predict model. Here we will analyze and prepare data to perform regression techniques, right? So First thing we will do to check dimension of the data frame in terms of row and column, then check data types, ensure your data types are correct, refer data definition to validate. Okay, then third we will do is if data type are not as per business definition, change the data type as per requirement. Okay, study summary statistics. Now checking for missing values, study correlation and detected outliers. Finally, what we will do is we will display the shape of our data, that is we have 2000 row and 21 columns. Data frame has 21 columns and 2000 rows, right? If we get the number of row or display all the columns, sorry, if we get the number of column or display all the columns, so we have df dot column, which will return all the column name that we have in our data set. Next thing we have is the data type. So df dot d type, so these are all our data types, right? So here you can see that we have two float variables, that is clock speed and md. So from the above output, we see that except for the columns of clock speed and mdeep, all our column data type is in int 64, right? Categorical column blue, dual sim, 4G, 3G, touch screen, Wi-Fi price, ranges. So these are categorical columns which will contain our continuous data. Now let's check how the distribution and frequency level for those columns. So check value counts for price range. So to check how the distribution and frequency table for these column, we will do pd dot value counts df of price range, right? So these are the price range that we have to check the value count for price range, right? 500 500 500 for 0 1 2 3. Okay, now classes are balanced here, we can see that. Okay, now pd dot value count dot df Wi-Fi. So how many values are there in the Wi-Fi? So for 0 we have 90 86 6, and for 1 we have 1014 for Wi-Fi, which is into 64. Now if we get the summary statistics, so what we will do is we will use the describe function here, which will describe all the statistics of our data set. So here the above output prints the important summary statistics of all the numeric variable like the mean, median, minimum and maximum values along with the standard deviation, right? So this is how we will get that. If we check the missing value, so here you can see that to check the missing value we are calling the isnull function and then summing all the isnull values. So it will return all isnull or we can say missing values here, right? So we are just printing the missing value, so this will return for every column. Now there are no missing value in the data set, right? Next thing, to do the correlation, again we will use the df.core function, which will return all the correlation among the data columns, right? So this is you can verify the correlation between, for example, blue, for example, blue FC, for example, with blue any score. So this way you can get that. Next thing, to get a correlation matrix, if we plot the whole data that we got here in a plot, right? So what we will do is in the correlation variable we are getting the df.core function, plt.figure, we are passing a figure size as 15:5. Now plotting the heat map. Okay, so correlation, that will give the correlation matrix here. CMap, that will give color code used for plotting. Vmax gives a maximum range of values for the chart. Vmin gives some minimum ranges of value for the chart. Now sns.heatmap is correlation. CMap is our, that we are giving what, our color code used for plotting. So this is ylgnbu. Vmax 1.0. so Vmax is basically gives maximum range of value for the chart. So that is Vmax 1.0, and Vmin minimum value in the range, that is -1. Now if we specify the name of plot, we are giving as correlation between features. Okay, so here you can see that the correlation between features. So here you can see how nicely it has plotted the correlation. All these diagonal value you can also verify, the darkest value, the lightest value you can also verify, right? So if we read all the observation, we can see that RAM is highly correlated with price range. So where is our range? RAM. So RAM is highly correlated with our price range. So if we check the RAM with the price range, so here you can see that the RAM and the price range is highly correlated here, right? You can see that, and here as well as here. Okay, so RAM with price range, RAM with price range. 4G and 3G also have some relationship. So if we check for 4G, 3G and 4G, 3G and 4G also have some relations, right? And PC, that is primary camera and front camera, are also related. Okay, so here you can see that primary camera and front camera are also related, and most of the features are not related to each other. Yeah, of course we can see that. And few features like clock speed, MDP, cross are not having much relationship with the price range and can be dropped. Yeah, we can do that. Now check frequency count between price range and RAM. So to check that between these two, we will use cross tab, right? We are just try to check the frequency count between the RAM and the price range. So if you do the cross tab, check the frequency count. So here you can see that 0, 1, 2, 3 for RAM, right? So all that what you will get is the RAM of the price range 0, 1, 2, 3. Let's move forward. If we talk about, we can see that as RAM increases, the price also increases, right? So I'm talking about this observation. So if you see that if the range increases, the price also increases, and if it is, and also it is very practical thing. If the RAM increases, the price also increases. So let's see the last price, last RAM, that is 3998. So the price is also the highest price. Now checking the pair plot. So if we check the pair plot for all these, so defining all the variables here, right, all the columns. Now SNS.pair plot, passing the DFF, diagonal kind is KDE, U is also there, price range, and markers is marker is OSDH, right? So plot.show, if we plot that, you will get this plot as here. If we check for discover outlier with visualization, so importance of detecting an outlier, right? So what is that basically? One of the most important tasks from large data set is to find an outlier, which is defined as a sample or event that is very inconsistent with the rest of the data set. The observation point or value would be distant from the other observation in the data set. So recollect that one of the assumption of logistic regression is there should be no outliers, right? So again, recollect that one of the assumption of logistic regression is that there should be no outlier. This is what the property we can say of the logistic regression, right? So this is why we need to detect the outlier. So let's create a box plot for all the continuous features. So we are passing the continuous features right here, you can see that, and passing the figure size. So this is the how all the box plot have been plotted. And now df.pxHeight.describe, if we check for the px height only, so this is the describe, so that will give the all the values of count, mean, standard, minimum, and interquartile ranges. So as we know that pixel height can be 90, 60, there are no outliers, right? So pixel height can be 90, 60. Okay, so yeah, there are no outlier for that. Now let's apply the logistic regression finally. So select independent features for model building. So for X we are getting the ilog of the, for X we are getting all the values except 1, and for Y that is accepted column of the X, that is price range. So we will get the price range in the Y. Now if we split our data in train test, so here we are splitting that, that is test size is our 30% and train size will be 70%. Random state we are passing at 42 here, so that is, so again for random state we will get the same data point each time. So that is how we pass any integer in this, right? So to get that all the data points same at all the time, if we do not give any random state, so each and every time you will get different data points, so that will lead to to work in your debugging. Now checking the dimension of the train and test subset. To print the dimension of train set, we are using xtrain.shape, and to print dimension of test set, we are using xtest.shape. So this is how our xtrain and xtest. Now if we check the x.head2, so for head 2 you can see that the top two values of the x, right? Now importing logistic regression and train on training test set. So from sklearn.linear model, import logistic regression. Model equals to logistic regression, we are passing random state of equals to 0, right? Here you can see that we are passing random state 0. So at this particular time it will give you any random number, right, for the random state. Now model dot fit, we are passing x train and y train. So if you get that, you will find the value c equals to 1.0, class weight, dual, fit, intercept, right? All the value that you will get: multi-class 1, and jobs none, penalty 12, random state 0, solver 1, tool, verbose, worm start, so on so forth. Next thing, we predict price range of test data. So y prediction equals to model dot predict, that is x test and y predict. Now let's measure the accuracy of this model's prediction. So accuracy score is y test and y predictions, right? So here you can see that this is what you will get, the accuracy score, that is y test and y prediction, and some other matrices. So for example, we have and some other matrices, right? So print classification report, we can get that from precision, recall, F1 score, and support. So this is what we will got from classification report, and we are passing y test, y prediction, and digits are 2. So on all the 2 decimal digits, that will return the values, and you can see that from classification report you are getting precision, recall, F1, and support. Now display confusion matrix. So again, confusion mat equals to confusion matrix, y test and y prediction. df of confusion matrix equal to pd dot data frame of confusion matrix. plt dot figure equals to fixed size, that we are passing 10 and 7. sns dot heat map, that we are passing df confidence matrix, that we are entering true, and cmap equals to blues, fmt equals to g. So this is how you will get the heat map, right? So now standardize the data. So let's do the standardization. So again, to get the standardization, we are first importing the z-score, right, to scale our data. Now applying z-score on independent features. So xtrain sc, that is xtrain dot apply z-score, and xtest sc, that xtest dot apply z-score, right? So this is how we have passed xtrain and xtest. Now fit the logistic regression model on scaled data. So model 1, that we are giving logistic regression, random state of 0, and model 1 dot fit xtrain sc and y train. So here you can see that logistic regression c equals to 1.0, class weight we are passing none, dual false, fit intercept true, so on so forth. You can see the logistic regression that we will get. Model 1 dot score equals to x train sc and y train. So here you can see that the score that we got is nearly 85%, and model score of, if we get for x test and y test, it is nearly 83% or 82%, we can say that. Y prediction that we have is model 1 dot predict, that we are getting x test sc, right? And right, and again, if we get the confusion matrix is our y test and y prediction that we are having in this confusion matrix, and df confusion matrix, pd dot data frame confusion matrix, right? Now plt dot figure is our figure size, that is 10 and 7, and if we call this sns dot heat map, so that is df dot confusion matrix, and note is true, cmap is blues, and fmt is g. So this is how you can see that the confusion matrix will look like. So if we call the model 1 dot classes, so yeah, all the classes in our model 1 0 1 2 3, all the return value, and model 1 dot intercept, all the values dot intercept. Here you can get that x test sc dot head. Now it is returning top two values. So here you can see that the battery power, blue, dual sim, every specification of that particular mobile. If we properly run the model 1 dot coefficient, so here you can see that this is how it will return all the values in one go, right, for the model 1 dot coefficient. So finally we can see that the conclusion, that is we can see high correlation with battery, px height, px width and RAM. So if you check that high correlation with battery, right, so this is how your battery, the high correlation it is asking, and px height, right, px width, right, and for RAM, so for RAM as well. Okay, now if we talk about the conclusion, so we are able to classify price ranges with an accuracy of 96%. Okay, RAM seems to be highly correlated with the price ranges. Okay, battery power is also a deciding factor of the price, right. New features like clock speed, mdep and cross are not having much relationship with price range, and standardization of data improves accuracy drastically. Okay, few cases were misclassified, however there were zero misclassification in far classes, like none of the low cost prices were predicted as a high cost, and hence we can say that our model is good for production. So let's read some comment that this is a classifier task, hence logistic regression is used here, right. So hope you got the idea behind a logistic regression on the classification problem, and we can apply any other classification algorithm like SVM, decision tree, KNN, naive Bayes, etc., and compare the result as well. We can see that price range dependent variable is linearly dependent on a few independent variable like RAM, battery, height, width. Hence it makes sense to use logistic regression. Okay, since logistic regression is interpretable, we can infer which features are influencing price range the most. So yeah, this was all about the case study on the mobile price classification, right, which is a classification problem of supervised learning, and hope you got the idea how we apply the logistic regression on that. So yeah friend, this was all about today. So we'll come up with another video. Stay tuned. All the best.